Look deep enough beneath the surface, and the world goes completely dark. The most critical resources on our planet are locked inside an environment that humans cannot physically see. This creates a massive blind spot, known as geological uncertainty. Engineers have to make high-stakes calculations about things they can never directly observe, guessing at the exact shape of rock layers, the location of hidden fault lines, and the unpredictable movement of deep underground fluids. Because we have to rely entirely on limited, indirect signals, every major exploration decision is, in reality, a multi-million-dollar gamble. You cannot guarantee the exact layout of a target you cannot see. In the deep subsurface, absolute certainty is a physical impossibility. For decades, the traditional approach in the industry was to fight that reality. Teams relentlessly searched for a single, definitive map, a fixed set of coordinates that would state exactly where the oil was hiding. This logic visualization highlights the flaw in that thinking. When you take a single, rigid forecast and try to apply it to a rapidly fluctuating, chaotic environment like the actual Earth, the math breaks down. Treating a fragile, highly variable assumption as an absolute fact leads engineers to drill into the wrong zones, resulting in catastrophic operational failures and massive financial losses. To actually master the subsurface, the industry had to stop trying to artificially erase ambiguity and instead develop a way to mathematically map the unknown. This is where OmniPetro operates. The platform entirely abandons the idea of a fixed geological puzzle, treating the Earth exclusively as a probabilistic system. Instead of asking the flawed question, "Where is the oil?" the system asks a more precise one: what is the exact mathematical probability of its presence? To answer that, the AI uses scenario simulation. OmniPetro rapidly duplicates the target area into thousands of parallel realities. Across these grids, it tests endless combinations of rock formations and fluid flow, rapidly comparing potential outcomes and operational risks at the exact same time. By digitally exhausting every possible success and failure before a single physical drill is deployed, OmniPetro transforms chaotic, unseeable variables into a structured matrix of probability. Those thousands of abstract data points from the simulations are incredibly complex, so OmniPetro collapses them down into a single, actionable output, the risk map. This topographical map categorizes the subsurface. Bright green zones indicate statistical safety, while deep red flags high hazard. The AI mathematically resolves conflicting data points, physically shrinking those red areas of uncertainty. Engineers then plot their exact trajectories, deliberately weaving through the safe green zones. Mapping the risk is just as crucial as mapping the resource itself. When you can clearly define the boundaries of what you don't know, you reduce the probability of failure. Crucially, OmniPetro's probability maps are never finished. The system operates on a continuous learning loop. The moment a real-world drill finally penetrates a new rock layer, it generates live, empirical data. That physical contact triggers an immediate feedback loop. The live operational data surges straight back up the wellbore and feeds directly into OmniPetro's neural core. Presented with new physical truth, the system instantly self-corrects. It recalibrates its previous estimates, recalculates the probabilities, and refines the overall map in real time. The platform evolves through action. With every physical operation, the digital ecosystem incorporates new evidence, becoming mathematically smarter and more accurate. Yet, despite all of this computational power, OmniPetro does not make the final call autonomously. It functions entirely as a highly advanced decision support system. There is a strict division of labor. The AI carries the weight of calculating infinite variables, freeing human geologists to apply intuition, contextualize the physical environment, and exercise mastery over the operation. Through this collaborative synergy, expert teams can look at a highly refined, mathematically sound matrix of probability and confidently execute billion-dollar exploration strategies. Inside OmniPetro, uncertainty is no longer a blind spot to be feared. It is an integrated, calculable part of the exploration process, deliberately utilized to illuminate and navigate the darkest unknowns of our planet.